Today what I want to talk about is stoichiometry. So stoichiometry is multiple ratios in equations. So this is why we have to balance chemical equations. We're going to look at the coefficients, and we're going to set them equal to moles and set them equal to each other, etc. So for instance, right here, I have a balanced equation. This is nitrogen plus hydrogen to form ammonia. And so let's look at this. I got 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. And so to make ammonia, and we use this gas to make fertilizers and stuff, we need to have this correct ratio, a 1 to 3 to 2 ratio. So we write chemical equations in terms of moles. And I set them equal to each other. So this is our new equivalent relationship. That's probably the biggest difference now, is that I set this now to be our new equivalent relationship. And we're going to use that. We're going to use that to predict this. Okay, if I have so many grams of nitrogen, how many grams of hydrogen am I going to need to react with that? Or probably more importantly, say I want to make 10 grams of ammonia. Well, how many grams of hydrogen and nitrogen am I going to need for this reaction? So let's take a look at this one right here. I say, well, how many moles of H2, so how many moles of H2, of hydrogen gas, will react with 5 moles of nitrogen, and then I want to convert to grams of hydrogen gas. Well, when I look at it, I'm going to look at this ratio. 1 mole of N2 reacts with 3 moles of hydrogen, and so I'm going to write it now as a unit factor. So again, we write unit factors. This is an equivalent relationship, 1 over 3 and 3 over 1. So it says, how many moles will react with 5 moles of nitrogen? So what I'm going to do is I write down what's given. The what's given is going to be the 5 moles. It's always the one in the original problem, so put that over 1. I need to end up with moles of H2. So what I'm going to do is I'm going to use unit factor number 2. So I know that 3 moles of H2 will react with 1 moles of nitrogen. When I do that, I'm going to end up with 15.0 moles of hydrogen gas. So basically, I need 15 moles of hydrogen gas to react with 5 moles of nitrogen gas. And this ratio has to be consistent, otherwise you may not end up with ammonia. So again, we balance it and we use these ratios to predict the amount of products, reactants that we're going to need for these chemical reactions. And we use it for everything. I mean, if you're making aspirin, Tylenol, you write a balanced chemical equation, you need a correct ratio of reactants, etc. The second part is, how many grams of hydrogen gas are we going to need? So basically, the only thing we're going to do is convert moles of hydrogen gas to grams. That's all. We don't use that balanced chemical equation for that. I wrote the molar mass. Again, this is something we've been doing now. It's 2.02 grams per 1 mole. So basically, so when I do that, I'm going to end up with 30.3 grams of hydrogen gas. So don't let this 15 sway you. Whenever you convert from molar mass, it's always 1 mole and that molar mass of that substance. So let's continue with this. Second one is, how many moles of NH3, so in this case, how many moles of NH3 will be produced from 6.5 moles of ammonia? So in this case right here, and again, well, I should say it's N2, so sorry. 6.5 moles of N2. So in this case, 1 mole of N2 will produce 2 moles of ammonia. So I have a 1 to 2 ratio. I wrote it as unit factor. 1 mole of N2 over 2 moles of NH3, 2 moles of NH3 over 1 mole of N2. And again, I get these ratios from the balanced chemical equation. That's all it is. I write those numbers, I just call them moles with that. So to do this now, I write down what I start off with. Again, it's always the one in the original problem. I need to end up with moles of ammonia. So I want ammonia on top, so I'm just going to use unit factor D. So when I do that, I'm going to end up with 13 moles of ammonia. Let's go ahead and convert it to grams of ammonia, because we always going to go from moles to grams, because in the lab, if somebody says, well, I'm going to make 13 moles of ammonia, so well, how many grams is that? So at that point, we'll just use a molar mass of ammonia. I wrote it here, 17.04. So 1 mole of ammonia weighs 17.04 grams of ammonia. That's just the molar mass. So when I do that, I'm going to end up with 91.1 grams of NH3. I went back and changed it. 13 times 17 is going to be 222 grams. So again, it's 222 grams, not the 91 I wrote. So for the last one, 15.5 grams of H2 will produce how many grams of NH3? So a couple of things is that, remember, these things are written in terms of moles. So I'll look at this. 3 moles of H2 will produce 2 moles of NH3. I write those as unit factors. 2 moles of NH3 over 3 moles of H2. 3 moles of H2 over 2 moles of NH3. Now, this is a little bit different because in this case, I started off with 15.5 grams of H2. So before I can get to moles, I got to convert to moles. I got grams of H2, so convert to moles like you normally would. I got the molar mass. From that, I can get to moles of NH3, which is what I want. And then finally, I can go from moles to grams. Again, it's a 3-step process. If I give you something in terms of grams, always convert to moles, because that's the only way I can use a mole to mole ratio. So 1 mole of H2, 3 moles of H2 will form 2 moles of NH3. So basically, I'm using this unit factor, and then I got to convert it back to grams. So again, I use the molar mass. Always be aware. Don't let this 2 sway you. I mentioned a couple of times. Molar mass is always per 1 mole. It's always per 1. This is for the balanced chemical equation. It has nothing to do with the molar mass. So if I do that, I'm going to end up with 87.2 grams.